there's one skincare ingredient that works, it's retinol. Pretty much everyone agrees whatever skin concern you have, it's one of your best bets. But is it all a scam? Quite a few dermatologists and scientists don't think retinol works.
There is very little, if any, trustworthy evidence available to support the use of retinol-containing products to improve the appearance of aged skin.
I think they are a total waste of time and money.
And I can see where they're coming from. When I started looking at skincare during my medicinal chemistry PhD, I saw a huge difference between what scientists are taught is good evidence and what I was seeing for skincare. But after 12 years of studying skincare science, learning about the cosmetic industry, and getting qualified as a cosmetic chemist, I feel like I can finally explain to you why skincare science looks so unsciencey and how to find products that work. Now, some of you are probably thinking she's just defending the scam because she's been sponsored by skincare companies, but a lot of non-sponsored scientists and dermatologists agree, and once I break it down, I think a lot of things that you've noticed about skincare will suddenly make a lot more sense, and you'll find it easier to pick out evidence-based skincare products. Retinol is a retinoid. These are ingredients based on vitamin A, and they're the superstars of skincare. They work for lots of things like acne, pigment, and wrinkles. But not all of them have the same level of evidence. Some of these are drugs, they have been extensively studied, and that's where a lot of that great reputation for retinoids comes from. But what about retinol? PubMed is a database where most peer-reviewed clinical trials are listed. This is where products have actually been tested on someone's skin and then other scientists have looked over the study before it got published. If we do a really basic search for retinol clinical trials, it's not really looking great. We've got 39 results and a lot of these aren't actually on retinol on skin. This is a pretty typical retinol study that you'll see, and it's actually one of the better ones. We've got 40 subjects, which is pretty low by medical standards, but actually really good by skincare standards. It's placebo-controlled, which means the skincare product was compared with a cream that didn't have any actives. It's double-blind, which means both the volunteers and the people taking the measurements of the skin didn't know which product was which, so they are hopefully less biased. But you can see here we've got retinol. It's also combined with lactose and glycolic acid, so you don't actually know if it's the retinol working or if it's one of the other ingredients. Most of the authors are also from Johnson & Johnson, which is the company that makes the product, so there is a potential conflict of interest there. And we haven't even opened the paper yet, so I'm sure once we get in there, there'll be even more issues. So why does the evidence for the best skincare ingredient look like this? Well, a lot of this is the government's fault.
Thanks, Obama.
Most countries draw a line between drugs and cosmetics. Drugs are defined as products that can treat disease or they can change the structure or function of skin. Before an ingredient can become a drug, it has to go through an approval process. This involves doing a whole bunch of studies, including on lots and lots of people, to show that it is actually effective. The company then takes all this data and submits it to a regulatory agency. They make sure there's enough evidence to say that it works, and it becomes a drug. On the other hand, cosmetics are defined as products that have superficial effects. They just change the appearance of skin. Retinol is classified as a cosmetic, so this kind of makes it seem like retinol doesn't work. It feels a lot like this.
Do you know what they call alternative medicine that's been proved to work? Medicine.
What this is missing, and this is crucial, a lot of the time whether something becomes a drug is less about what it does and doesn't do, and more about other reasons. This drug versus cosmetic definition was created almost 100 years ago, before we, as a species, realized bloody everything can change the structure and function of skin, at least in little ways, including water and even just a piece of plastic tape. I mean, look at these effects. It is pretty intense for something that literally just sits on top of your skin and doesn't even go in. And some ingredients are drugs in one country and cosmetics in other countries. It's not like you can tell a molecule what it can and can't legally do to your skin after you've crossed the border. You just can't. They won't hear you. They don't have ears. So this is a common misconception. How cosmetics are legally defined doesn't match what cosmetics are actually doing to your skin. But at the same time, it would be ridiculous and unnecessary to regulate water and sticky tape as drugs. The way it mostly works in practice is that cosmetics aren't meant to claim that they can change the structure or function of skin. And if cosmetic companies start selling really potent and potentially dangerous stuff, then the government steps in. But with retinoids, you might be wondering, they all kind of do the same thing, they work in the same way, but some of them made it to the drug side. Why is retinol over here? This is a really good question, and it's almost entirely a historical accident. Here's a dermatologist who was involved in the original research on retinoids for skin.
How did it come about that retinol is over the counter and retinoids are prescription?
The reason is retinol has been in a lot of products, including cosmetics, for a long time for its antioxidant properties. So it was already in over-the-counter products. And then as it became apparent in the work of Se-Wan Kang and John Voorhees, where they showed retinol was a pre-drug of retinoic acid, once we became aware of all that, then obviously retinol might have some benefit. And it clearly does. And there are many, many good, really good studies that show that's definite benefit. So the FDA couldn't say, well, we can't allow this over the counter because it's already there, for another reason, just at a different concentration.
So there are some good reasons why retinol isn't legally classified as a drug. But if it works, then where are the scientific studies? Here's the thing with the peer-reviewed scientific literature. Not everything has an equal chance of ending up in here. There are a lot of good reasons why we don't see high-quality peer-reviewed clinical trials on cosmetics that often. Yes, one of these reasons is that a lot of stuff probably doesn't work that well. But a really important reason that gets missed a lot is there is just not that much incentive to do them. Research costs a lot, especially clinical trials. Most peer-reviewed research is funded by taxes. It's a lot easier to get funding to research heart disease than skin. And within skin research, it's a lot easier to get money to study drugs approved to treat medical conditions than how retinol makes skin look nice. That means more skin studies are funded by ingredient and skincare companies, which isn't as nice because there are potential conflicts of interest. But even if the studies were 10,000% honest, that still changes the sorts of studies that get funded. As someone who owns skin, I would love more high-quality clinical trials on skincare. It's nice, simple, direct evidence. You literally put the thing on a bunch of faces and see what happens. But that's not how companies think. They don't have skin. Back to the government. Companies are going to do less trials on cosmetics. Clinical trials are actually needed before you sell a drug, but cosmetics don't need them. If a company doesn't need to pay for an expensive thing, they are probably not going to pay for that expensive thing. And it is expensive. Back when I had less back pain, a proper clinical trial for a dermatology drug cost $11.5 million, not adjusted for inflation. That drug versus cosmetic definition means that even if a cosmetic did something in a clinical trial, the company can't just slap that on a billboard. So it isn't exactly the most guaranteed return on investment compared to everything else a company could spend their money on. Let's say a company has decided to pay for a clinical trial, and they often do despite all of these barriers. Well-designed experiments are a great way to test what works and make better products. Yay, scientific method! But publishing a study in a peer-reviewed journal is a choice. The company could also just not publish it and just use the findings to improve their own products instead of giving free info to their competitors. And this happens a lot. I've consulted for some companies who invest a lot in R&D, and it is extremely obvious that what we actually see is a tiny sliver of the actual research they've done. Now, for academic scientists, doing good research and not publishing it in a peer-reviewed journal is super weird. I know, because academia is where I was made. And it's because the incentives are so different there. Part of why academics publish papers is because it contributes to scientific knowledge. It's just how science is done, and that idea contributes to a lot of industry publishing too. But a very big part of it for academics is that's how you keep your job. It's publish or perish. Your peer-reviewed publications are really important when universities decide who to hire and who to promote, and when research funding gets decided. So the peer-reviewed studies that do come out are going to lean towards maximum benefit to the company at a minimal cost. And a lot of the time, this is just the opposite of good study design. For example, a well-designed trial to test retinol would mean it's tested on its own against a vehicle control. That means you're testing a cream with retinol against the exact same cream without retinol to make sure it is that retinol working. If you're a big cosmetic company, you've just paid a whole bunch of money to show that retinol, an ingredient that every other company can use in their products, works. On the other hand, you could spend the same amount of money and test your specific retinol formula against a plain cream, or even against nothing, just to rig it a bit and make your product look better. So if you're looking at it as purely an investment, it kind of leans very much one way. Well-designed also usually means more participants. Repetition is really important in science. The more times you test something, the more confident you can be that your result isn't just a one-off fluke. In drug trials, they'll test on hundreds or thousands of people. Most cosmetic trials have less than 30 people. Why would you pay for 300 people when you could just pay for 30 and still be doing more than everyone else? So there are a lot of reasons why a cosmetic company probably isn't going to pay big bucks for a well-designed clinical trial on retinol that they'll publish in a peer-reviewed journal that ends up on PubMed. The only real incentive would be to get new customers who are nerdy enough to be impressed by a well-designed clinical trial, but they don't already think retinol works. This is a really tiny group of people. Again, just an awful investment. Especially since pretty much everyone who understands retinoid pharmacology accepts that at least some retinol products work. So why? Why do so many scientists think retinol works, even though we don't have that many high-quality clinical trials? Even Kligman, who invented tretinoin and has a reputation for maybe hyping it up a little bit too much, even he says retinol, which is a competing ingredient, works. I love clinical trials. I think all scientists do. Thing go on face change, nice.
Nice.
But I think sometimes we forget that the whole point of science is to build an understanding of the world so we don't have to directly test everything. Clinical trials have been important for such a long time because human biology is really complicated. Clinical trials aren't really used for better understood areas of science like astrophysics. It can be hard to accurately predict what happens when you take a pill. The ingredients have to travel through your digestive system, get absorbed, go into your blood, get processed by your liver, and then end up in the right part of your body before it works. But skin products are less complex. They just have to go through a relatively short distance through your skin, so it is a lot easier to work out what's going on from other types of evidence. And our scientific understanding of human biology is also improving. For example, in toxicology, there's been a lot more use of new approach methods instead of just directly testing on animals or people. And this sort of scientific reasoning and extrapolation is used in clinical trials too. If a drug works in a clinical trial in one place, we assume that it's going to work in lots of other people, in lots of other places, maybe years after the original. And that's because thanks to science, we know that human biology doesn't evolve that quickly. Drug molecules aren't really affected by where you are. Clinical trials for tretinoin didn't tell people whether they should be sitting or standing while applying it because, again, thanks to science, we know that's not going to change how it works. So there's actually a lot of other scientific evidence on retinol. And when you put it all together, it builds a really convincing case that if we had the incentive to do high-quality clinical trials, they would find that retinol works. One of the key pieces of evidence is that in your skin, retinol can be converted to tretinoin, which is an approved drug. There's a lot of evidence that tretinoin works, and we also know a lot about how it works, its pharmacological mechanism of action. So far, this isn't a slam dunk. We still need that tretinoin that gets formed from the retinol to end up in the right place, and at a high enough concentration. Luckily, we do have evidence for this. We also have evidence that applying normal amounts of retinol to skin will change the level of substances inside the skin. These are the same ones that change with tretinoin, and they're expected to be an important part of how tretinoin actually works. And for each of these, we have multiple types of evidence. We have studies on mice, on people, on bits of skin removed from people, on different types of isolated human skin cells. You might have also experienced some evidence for yourself. If you've ever used a little bit too much retinol, you might have noticed a special kind of peeling. It's not the same as the kind of peeling you get from other irritating products. There is a delay, and it feels like you just have a little bit too much skin. This is a pretty unique side effect of retinoids. It has a special name, retinization or retinoid dermatitis, and it happens because of how retinoids work. Activating retinoic acid receptors triggers the epidermal growth factor pathway, and this leads to more cells being produced in the top layers of your skin. There's also those not as high quality clinical trials that we do have. Despite all of this lack of incentive making the bar way higher for conducting and publishing them, retinol still has a lot that show promising results. And this evidence includes studies from independent research groups that don't have funding from cosmetic companies. A lot of the studies that were funded by cosmetic companies were done in conjunction with independent academic researchers. And the industry funding for these studies comes from lots of different cosmetic companies. There are also studies on other cosmetic retinoids with results that wouldn't really make sense unless retinol worked. It's just really unlikely that all of these scientists and companies are part of some huge conspiracy that's been going on for almost 30 years. So, in this situation where there are very good practical reasons why high-quality peer-reviewed clinical trials aren't there, and there is an overwhelming amount of other scientific evidence that something works, I think it's really reasonable to conclude that retinol probably works. Now, I'm not saying that you can't choose to only use ingredients that have well-designed clinical trials. That is a completely reasonable personal choice. But saying that the only ingredients that work are the ones with high-quality clinical trials and anything without that specific type and level of evidence is completely useless, that is actually unscientific. And there are some upsides that cosmetic retinoids have that drug retinoids don't, and I'll be talking about those in a different video. I've mostly talked about retinol, which is the skincare ingredient with the most evidence behind it. But there are a lot of other things that we can take from this journey that can help us find other effective ingredients. This is the Lab Muffin Matrix. It shows how to think about the evidence when you're deciding if a skincare product has a good chance of working. The left-hand side is about ingredients. You want to see if the active ingredient can theoretically work. This is looking at things like chemical properties, mechanism of action, cell studies, and animal studies. Do we know how it works, what it's interacting with inside the skin? Can it get into skin? You also want to see if the active ingredient has been actually tested on people's skin. We're looking for clinical studies and biopsy evidence. Now, the right-hand side is about specific product formulas. Again, you want to see if it can theoretically work and if that formula has actually been tested on actual people. Some ingredients are easier to formulate with, so you don't have to do quite as much guesswork. But others are more annoying, like if they're unstable, which is the case for a lot of retinoids. I'll be talking more about this, but a good general guideline is to look for products from companies who invest in product development. And for all of these, if there are more different types of evidence, more different scientists contributing to this body of evidence, more repetition of findings, you can be more confident about the conclusion. Once you have a retinoid product, you'll need to know how to apply it, so I take you through that in this video. The next best skincare active is probably vitamin C, and I have a guide to choosing those too.